Oh, it's you. Sorry, last time I didn't introduce myself. I'm Claudio Costantino, a PhD student from Università degli Studi di Perugia. Previously, we saw how a researcher could come into something unexpected. Well, the unexpected presence of lead calcium phosphate on ESRF analyzed artwork was the starting point of my research. Today, following how I structure my research, we will understand the steps taken. But let's start from the beginning. In every creative work, the starting point is study and preparation. As a painter draws on his sketchbook or an actor studies his script, in the same way, a researcher must prepare his work. This preparation phase is done by studying the scientific literature. In my specific case, I studied the state-of-the-art of lead calcium phosphate solid solution, trying to solve these main questions. Was lead calcium phosphate already found on artworks? And which techniques were used to detect it? Well, these compounds were found in several different artworks, such as Roman wall paintings, Egyptian papyri, oil paintings, and archaeological bronze. In some cases, the author supposed that the presence of lead calcium phosphate was due to degradation processes of the original materials. And in other cases, the hypothesis is that lead calcium phosphate were intentionally used by the artist. The main used techniques were infrared spectroscopy, X-ray diffraction, and scanning electron microscopy. In which other environments is it possible to find these compounds? Well, studying the literature, I came into a field of research that applies hydroxyapatite as a detoxifier in heavy metal polluted environments. Hydroxyapatite in an aqueous environment can switch its calcium cations with another bivalent cation, such as lead. So there is the formation of a new compound, where calcium can partially or totally substituted by lead, forming lead calcium phosphate compounds. This was a great piece of information for my research. It is a chemical reaction model that can be the grounds for understanding what happened in real cases. Now let's go back to the lab and see some more practical activities. The following research steps are the laboratory experiments. Let's see what I planned and did. Firstly, following a scientific paper, I synthesized 7 different lead calcium phosphate compounds, from the 10% to 100% of lead presence. These synthesized compounds were characterized and compared with the standard hydroxyapatite, using different techniques. Some were performed here in Perugia, such as infrared spectroscopy, Raman spectroscopy, and X-ray diffraction. I also performed synchrotron analysis at ESRF. The obtained database highlights how the increasing presence of lead inside the crystal produces some measurable changes in the structure parameters. This means that by measuring those parameters, we can identify which lead calcium phosphate compound is present in a sample. As you can easily imagine, an artwork is a complex system. For example, in a painting, there generally is a support, a preparation layer, different pigment mixed with binder, and a varnish. For this reason, I decided to create paint model. This experiment will help to get a little bit closer to a real artwork, trying to imitate it. I prepared 4 different sets and let them naturally age in a dark condition for approximately 1.5 years. The first set is made by oil and lead calcium phosphate compounds. The second one by Arabic gamma and lead calcium phosphate compound. The third one with hydroxyapatite and lead based pigment and oil. The fourth and last one with hydroxyapatite, lead-based pigments and Arabic gamma. The first two sets helps to understand if lead calcium phosphates are stable over time, and I choose the two most common binder classes used in art. One is lipidic, the oil. The other one is proteic, the Arabic gamma. With the two other sets, I did something different. I put in the same environment hydroxyapatite, which is a common material used in art. It is present in different pigments, such as black bones, and I mix it with lead-based pigment. This because I wanted to see if these two materials put closer in an environment that is not aqueous can still produce any lead calcium phosphate compounds. Briefly, the results are that the lead calcium phosphates mixed with binder are stable after over a year and a half or natural aging. But the second set, applying the database, I found the formation of a new lead calcium phosphate compounds. This means that the chemical substitutional model that we saw at the beginning is also relevant for artworks. The last but crucial step was the application of the database to real cases. I got the opportunity to investigate a Roman wall painting from the Netherlands, where there was the suspect of the presence of lead calcium phosphates. So, I got the chance to analyze them with infrared and Raman spectroscopy, and after that, applying my database, I recognized the presence of lead calcium phosphates, more specifically a compound with a percentage of lead between the 70 and the 80%. The application of the database on a real case closes the loop of my PhD research. We saw the initial part of a study, the creation of a hypothesis, and a series of experiments which are necessary to confirm or deny that hypothesis. Next time, we will talk directly with a professor and a researcher, and we comprehend which are the perspective and application of this study. So, see you next time.